Welcome to this explainer. Okay, look up at the sky. On a clear day, it looks totally empty, right? That actually, right now, there's a massive, completely invisible battle happening right above our heads. It's this high-stakes clash between the natural forces trying to cool our Earth and modern pollution trying to heat it up. And the winner of this invisible fight? Well, it's pretty much going to determine the entire future of our climate. Okay, let's dive into this. If you've looked outside during a bad fire season recently, you've probably asked yourself this exact question. Why is the smoke so much thicker these days, and why does it seem to just hang in the air for days or even weeks on end? To really get the answer, we have to look past that thick, visible smoke and zoom way, way in to check out the invisible chemistry of our sky. Section 1. Meet Earth's invisible cleaner. Let's introduce the unsung hero of our atmosphere. So the crucial point here is that our planet actually comes with its very own built-in cleaning system. It's called the hydroxyl radical, or OH for short. Think of OH as Mother Nature's invisible detergent, or honestly, it's a lot like a microscopic Pac-Man just flying around the atmosphere. Its entire job is to chomp away and scrub out harmful pollution, toxic smoke, and potent greenhouse gases like methane and carbon monoxide. It is literally the primary way the Earth naturally removes all this bad stuff from the air. But here is where it gets absolutely mind-blowing. Our little hero is incredibly rare. The global average concentration of OH is only about 0.4 parts per trillion. To put that into perspective, if the entire atmosphere was a giant swimming pool, OH wouldn't even make up a full drop of water. And not only that, a single OH radical only lives for about 1 to 2 seconds before it just vanishes. Yet somehow, this tiny, ultra-fast molecule does the heavy lifting of cleaning gigatons. We're talking billions of tons of reactive gases from our entire atmosphere every single year. It's wild. Section 2. The 52 by pollution problem. Because as amazing as Earth's invisible cleaner is, it's currently losing the battle. To figure out exactly who's winning this fight, scientists had a bit of a problem. They used to measure the natural cleaners and the human-made pollution using completely different types of math. It was basically like comparing apples to oranges. So researchers created what they call a ppm-based accounting framework. ppm just stands for parts per million. Basically, they finally decided to use the exact same ruler to measure both the dirt and the detergent. By putting the OH cleaning supply and the global pollutant demand into the very same unit of measurement, they finally got a clear picture of the battlefield. Now, what's really interesting, and honestly staggering about this, is this number right here, 52x. When researchers ran the numbers for the year 2023, they found that the total demand from reactive pollutants was 52 times greater than our natural OH cleaners could handle. Our microscopic Pac-Man are completely surrounded and totally outnumbered. Scientists actually have a special term for this massive 52x deficit. They call it oxidative inundation. I know, it's a very clunky scientific phrase, but it simply means that the pollutant levels have completely overwhelmed the atmosphere's natural cleaning supply. And because there just aren't enough OH cleaners to go around, harmful greenhouse gases like methane end up sticking around way longer than they should. They trap more heat, which scientists point out is causing a planetary energy imbalance. Basically, the Earth is hoarding about 1 extra watt of heat energy for every square meter of the planet. Section 3. The toxic feedback loop. This brings us to the villain's secret weapon, because things aren't just getting worse. They are actively feeding on themselves. Let's move on and see how this builds into a really dangerous cycle. Step 1. The planet warms up because those greenhouse gases aren't being cleaned out. Step 2. That accelerating warming dries out our forests, which leads to way more extreme wildfires. Step 3. Those massive fires pump tons of toxic smoke right into the air. And get this, that smoke actually consumes the remaining OH radicals. And finally, step 4, because the smoke ate our cleaners, there is even less OH available to remove the methane, which just leads to even more warming. It is a vicious, self-feeding cycle of destruction. Section 4. The fast and long game. Don't lose hope just yet. We have some incredible science stepping up to the plate. Let's look at a two-pronged technological team-up proposed to fix this mess. The strategy here relies on two completely different but amazing tools. On one side, we've got direct air capture, or DAC. This is a technology that literally sucks carbon dioxide right out of the air. Since CO2 stays in the atmosphere for a super long time, this is what we call our long game.
On the flip side, we have OH dispersal. This is a proposed tech to intentionally release extra OH cleaners into the sky to rapidly clear out short-lived pollutants like methane and wildfire smoke. This is our fast game. And the best part? These two aren't competing. Instead, they act as a strategic one-two punch to save our sky.
As one of our sources perfectly states, DAC is the long game, OH dispersal is the fast game. We need both. While direct air capture does the heavy lifting to structurally stabilize our climate over the next century by targeting that long-lasting CO2, enhancing our OH supply gives us fast relief today. It attacks the methane and the smoke that are causing the immediate dangerous crises right outside our windows.
When we combine these approaches, the benefits are just incredible. By adding more OH, we get immediate air quality wins, meaning less persistent smoke and way fewer hospital visits during fire season. It also gives us rapid near-term climate cooling by destroying those potent heat-trapping gases. This crucial cooling buys us the time we desperately need to make deep emissions cuts. And finally, combining all this with DAC ensures long-term safety and climate stabilization. It's how we finally break that toxic feedback loop and give humanity a fighting chance. Section 5, protecting communities right now. Developing and scaling up massive climate technologies definitely takes time, but people are breathing in thick smoke today. And this brilliantly illustrates how we can deal with that on a local level. The Kamloops HEPA filter program is an amazing blueprint for real-world, ground-level protection against air quality emergencies. The program specifically prioritizes vulnerable people, seniors, kids, people with asthma, and low-income households. It gives them true HEPA filters, which are incredibly effective and capture 99.97% of harmful microscopic smoke particles. Best of all, it makes things super easy. They use simple math to size the filters for different rooms, they offer vouchers, and they even do local drop-offs for people who need assistance. But, just handing out filters isn't enough on its own. The program also focuses heavily on keeping the community informed. They're tracking the harmful smoke particles known as PM 2.5 using real-time sensors all across the city. They're expanding public alerts and creating clear dashboards so everyone knows exactly how bad the air is on any given day. And they're doing multilingual outreach and hosting pop-up events because saving the planet has to include safety and equity at the neighborhood level, making sure everyone understands the risks and gets the tools they need to stay healthy. We've seen the massive 52 times deficit in our atmosphere. We've seen how the toxic feedback loop makes warming and wildfires so much worse. But we've also seen the incredible potential of the fast game and the long game, OH dispersal and direct air capture. So the real question is, will we step up and use this one-two punch of technology to finally break that feedback loop and win the battle for our sky? The invisible chemistry above us is waiting for our answer. Thank you so much for joining me for this explainer, and hey, keep looking up.